Hey, good morning, scientists. It is a Thursday, April 2nd, and welcome to science class. We have um, today, I want you to pause this and go grab your model drawing if you don't have it in front of you. If you haven't started yet, or you're still in the planning stages, that's okay as well. All right, so Bell work on Go Formative. So I see that some of us need to get started on that. Hopefully, that's not a computer issue. Um, but so I see some of you just kind of plowed through it, which is fine, and some of you are taking it 5 minutes at a time, 5 questions at a time. That's what I would do if I were you. That way, every day you can spend a little bit of time. Uh, you know, you just block out 45 minutes you can work on every class. Um, but obviously, you've got all your work and you got to try and figure out how to get it done. So today, we're talking about the water cycle model test. All right, that you may have started yesterday. I know some of you did from the comments that you put as well. All right, so let's take a look at our bell ringers. So there's a couple questions here I wanted to take a peek at. They are lowest scoring questions, and they just are a little more difficult. All right, so let's look at number 4. And if you got a Chromebook or a computer, why don't you go ahead and pause the video, and then why don't you pull this up? Um, Actually, never mind. Let's look at it here and then you can pull it later. All right, so the question says if you're using this blank graph paper for a graph, what intervals would you use for the y axis? All right, so where is the y axis? All right, which one of these is the y axis? All right, excellent, good job. The y axis is on the left hand side. Okay, I know you all said the right answer because you're awesome. So, so if this is my data, that's going to go on this axis here. Okay, what data am I going to use? I'm going to use this data right here. So first thing I do is look up and see my data. So my data has a range. All right, a high of 92 and it has a low of 42. All right, so that's a difference of 50. Okay, that's a difference of 50. Right? Not to mention, um, if you start on 0, it's really a range of 92. So if you got a range of 50, we've got to cover on this graph. We could do a break and scale and go 0 and then jump to whatever you want. Well, then you got to figure out how many lines do I have. All right, so I'm going to leave a couple lines here uh, for labels and things, but I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I got about 20. All right. So so I've got about 20. All right. Um, 20 lines. Right. I've got 20 lines, and I need to cover 50 degrees. Okay, 50 degrees. So the easiest way to do this is just to divide and see what each one should be, right? So if I take 20, all right, and I divide 50 into groups of 20, all right, I can drop my zeros. All right, that's 2 divided by 5, right, which is going to be 2.5. That's what my interval should be. Now, that's not a good interval. So what's our best closest thing? Right? Is it going to be 1? Is it going to be 50? Is it going to be 10? Or is it going to be 5? Just think if we go back up, here, um, we're trying to go from 42 to 92. So if I come down back to my graph, how am I writing all left? 42. So if I go by 10, so it'll be 42, 52, 62, 72, 82, 92. So then that would be my stopping point. If we go by ones, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. We can already see I'm not gonna get there. All right, not gonna get to the spot. So go through each one and see what's the best interval. And remember, interval is the value in between each lines. How much is that worth, right, on that graph? All right, and our second we're looking at is going to go on number 8. And on number 8, Um, it says, after observing the model, what do you know about air particles in relation to altitude? Right. So relation meaning how are they connected, right? Just like your relatives or or people you have a relationship with. How are they connected? And to altitude, right? All right, and altitude obviously is we're talking about height away from Earth's surface. So we go back up to the model. We're going to look at the model, right, and take a peek at it and say, what's happening to air pressure? Where is air pressure uh, going to be the highest? So we take a look at your model, take a look and understand what we have here. We have sea level on the bottom. We have top of the atmosphere, right? So this is right before space, and the little blue dots represent where the air is, and you can tell that it's not evenly distributed, meaning that there's more of them in certain areas, and things. And when you look at this, you want to think about something here. Why are there more blue dots in the bottom? Why are there less blue dots here? So I wonder what's happening. This is the Earth down here, right? So I wonder what force would be pulling down on here. So you can think about the different Earth's forces. You got magnetism. Earth's a big magnet. Um, you could have force that they're just pushing down on top of each other, kind of like something heavy jumps on you. Have you ever, you know, somebody jumped on top of you and then a bunch of people jumped on top, right? But really, the reason that feels that way is because of gravity. Gravity is pulling down on everyone and is pushing down on you. Um, so gravity is what's causing these air molecules to stay lower. All right. So we go back to the question now. All right. Where is the air column, which is that's the model is? Would you predict has the greatest air pressure? Right. So remember, pressure is consistent, constant force. All right. That's always going. So that is not pressure. Right. That's not consistent and constant. Right. Pressure is going to be pushing on your arm and holding it and holding it. Right. That's what pressure is. All right. So looking at this model, at what spot would you have more air pushing constantly on everything there? And that's what we're looking for there. So go back and look at number 4, number 8, if you have not done so. All right, as well. Um, and we're going to go jump back to our real purpose here today, which is this model. All right. All right. So you're going to draw your model. So one thing I want you to think about um, is is really focus on. I want you to think about: does every process have an energy? So touch your model if you haven't done right now. All right, go to each of your processes. Does evaporation have a cause? All right. Does he have an energy? All right. Go to um, transpiration. What causes transpiration? What energy source is causing that? All right. Condensation. What energy source or lack of energy source, a change in energy, is causing that? Go to precipitation, crystallization, and then runoff. Do they all have what's causing this energy or what's causing this water to change? Right. So as you're going through there, take your time and slow down. Look at this. Look at this through. Right. This is not due until tomorrow. It's our work for tomorrow as well. So today might be just a look at my rough draft. Look at what I have already. How can I improve it? Grade yourself on here. Right. Grade yourself on here, and if you don't have fours on all of these, then go back, reread, look over your journal, look over the things that you need. They can help you with that. So if you have questions or comments, um, uh, Google Classroom comment or email or remind are all great ways to get a hold of me. All right. Tomorrow we are going to have a Zoom at 10. Come with your models. Come to class with your models, right? And questions you have about the water cycle. And even if it's how do I show this? Even if you're like, I know the science, but I don't know how to put this down or show this in a model. Um, bring those questions tomorrow at 9 o'clock. All right. Thanks, guys. Good luck modeling.